All right, well, welcome everybody. Thank you for joining this afternoon or evening, depending on where you are. Today's session is going to be on sound effects and scripting. And so what we're going to be doing is, this is going to be a pretty beginner-friendly session. We're going to be doing some C# scripting to trigger sound effects, and we're also going to cover some of the basic sound components in Unity. I'm using Unity 4.55, so you guys should be able to follow along with that. And what I'll do is I'll just show you quickly the project that I have, and then I'll open up an empty project and we'll begin recreating it. Now, if you want to grab the assets for this before we get underway, I'm using the sample assets beta pack from the asset store, and I'm also using one sound from the Space Shooter project. From sample assets, you can grab the whole thing, and if you want from Space Shooter, you can just grab the audio files. So I'll just show you guys quickly what I've got here. This is the project as it's going to be when it's completed, and then I will open up a blank project and go. So there we go. You guys should be seeing Unity now. And so here we have like a simple scene. I'm using some of the assets from the prototyping tools. You should be hearing some footsteps. We're using the first-person character controller prefab. And what we can do is shoot these boxes and make lots of cool crashing sounds that have like a little bit of dynamism to them. They have some volume variation based on velocity, also some pitch variation so that they don't just sound the same every time. And the shoot sound has a little bit of volume variation as well, just to kind of keep it interesting. So, like I said, sort of a beginner focus, but I think there's going to be a couple techniques in here that will be helpful for everybody, especially those of you guys who are not so familiar with doing sound stuff. You know, as you can see, this is a super simple scene, but by adding some sound to it, it kind of really brings it together. So what we're going to do, I've got my sample assets imported here, and I'm just going to set up a really quick scene using some of these prototyping. So I'm going to the folder prototyping inside sample assets, prefabs, and then we're just going to grab this floor 16 by 1, drop it in, and reset the position. We'll drop it down to -1 units. We will throw in a directional light as usual, and then we're going to toss in the subfolder here, we're going to toss in our Smash Boxes prefab, and we're going to set that to 0, -1, or in this case, -0.9990. So stick that in the middle of our plane here. Next, we're going to pull in the first-person character controller prefab. So we're going to grab under characters, we're going to go to first person prefabs and drop that right in here, and let's slide that over so it's looking at our stack of boxes. When we drop the first person character in, this is a good moment to talk about one of the kind of core components of the audio system, which is what's called the audio listener. So the audio listener is, in this case, attached to the main camera that was created by default in our scene. And in Unity, you really only want to have one audio listener at a time. You can have multiple cameras. In this case, we're not going to need them. So what I'm going to do is I am going to delete this main camera, and with it, the audio listener. Now, the audio listener is a really, really simple component. It has no properties, and this is the output from your scene to your player's listening hardware, so headphones, speakers, anything like that. So what we're going to do is we're just going to highlight the main camera and hit delete. I'm pressing Command Backspace on a Mac to do that, and we are going to use the camera which is attached to the first-person character controller, which also has an audio listener as well. Let's just check that. Okay, so we can mouse our head around, we can jump, right? We should be hearing some footsteps, some jumping sounds. and everything is looking good so far. What we're going to do next is we're going to have our player be able to instantiate a projectile, basically shoot a little cube at this stack of boxes to knock it over and to trigger our sound effects. So what I'm going to do is I'm going to create that cube first. So we're just going to go game object, create other cube, move it over a little so we can see it. We'll set the scale to 0.25 on all axes just to make it a little smaller. And we're going to add a rigid body component by clicking Add Component. And that is going to be fine. And just for fun, we'll add a little material. There's a materials folder in the prototyping folder, and we'll just grab that green material, drop it on there. Good frame selected to see what that looks like. Very exciting. And we will call this our throwing cube. Okay. And now I'm going to make a folder in my project called prefabs. Not in here, that's okay. We're going to move it to the top level. And we are going to drop that throwing cube into our prefabs folder, and then we can delete it from the hierarchy. The next thing that we're going to do is we are going to create a location from which these cubes are going to be spawned on the player. So if you want to think of this as a gun, this would be like the gun that's shooting the bullets. So I'm going to go ahead and create a cube. Now, strictly speaking, we don't need a cube. I just find it's easier to position it when I can see a piece of geometry. And we'll call this throwing hand. And what I'm going to do is I'm going to child it to the camera so that when the camera moves and rotates, our throwing hand is also going to move and rotate. And so then what we're going to do is we're going to reset the position of that so that it moves to where our first-person character is. And I'm actually going to just turn on the mesh renderer for the first-person character, which is just a capsule, but it's just going to help us to see what's going on here. The throwing hand will also just make it a little bit smaller. We're really just going to use the transform of this, but anyway, I just find this a little easier. And then we're going to move it forward 1 unit on the z-axis, so it's, or the z-axis if you're English. It's going to be just in front of the player, kind of at eye level. And if we hit play, there we see it blocking up our view very nicely, but as we can see, rotating and moving with the player. So that's going to be good. We're going to turn off the box collider. We can remove all these components. Box collider, cube, mesh renderer, none of these are needed. We're just really going to use the transform. The cube was just for positioning. Okay, the next thing that we're going to do is we're going to write a script that we're going to attach to this cube, which is going to be what's going to launch our cube. So I'm going to create a folder called scripts. Again, in the wrong place. Let's move it up. And I'm going to create a new C# script. Now, I'm using C# here. You could totally use JavaScript. We at the Learn team kind of tend to favor C# and use it a bit more, or use it almost exclusively. So it's a little easier to follow along with our stuff if you use C#, but you know, JavaScript or Unity script is also a perfectly legit choice. I'm going to double click this to open it up in MonoDevelop. Okay, and so the first thing that we're going to start with is a public variable of the type GameObject, which is going to be called Projectile. Next, we're going to have a private float called ThrowSpeed. And then in update, we're going to check if the Fire1 button has been pressed, and if so, we're going to launch our projectile. So this is really basic, kind of simple stuff, but hopefully for those of you who are very new, this is going to be interesting to see, maybe a review for some of the rest of you. And then we're going to use this to get into some sound stuff. So we're going to say if input.getButtonDown, Fire1. So we're going to check if the Fire1 button, which you can remap in the input manager, in this case it corresponds to mouse 1. If that's been pressed, what we're going to do is we're going to declare a new game object called throw this, and it's going to be equal to instantiate projectile. So projectile is the object we're going to instantiate. The position is going to be transform.position. And so remember, because this is going to be no, not that. Because this is going to be attached to our throwing hand, that's the position that's going to be used. And then we're also going to use transform dot rotation, meaning it's going to take the rotation of that object. And before we continue, we're going to cast it to a game object. So we're going to say as game object. Next, we're going to add some force to the rigid body, and this is why we added a rigid body to that cube that we created. So we're going to say throw this dot rigid body dot add relative force, meaning we're going to add force to this, and we're going to do it along a new vector 3, which is going to be 0 on the x, 0 on the y, and then throw speed on the z or z axis. So we're going to throw the object forward along the z axis, and let's actually initialize throw speed. We'll set it to 2,000. Which is just a value I kind of came up with through testing. And as usual, I'm missing a parenthesis. Somehow seem to do that every single time. OK. And let's save this. Hopefully we have no errors. And we will toss it onto our throwing hand. Now, we have our slot for our game object that we saved, our prefab. So we're going to throw that in there, throwing cube. And let's give it a try. Play our scene. Pew, pew, pew. Boom. Very fun, right? So definitely fun to toss things around like this and knock things over and all that stuff. But not so juicy without sound. So the next thing that we're going to do is we're going to add a little sound for when we instantiate this object. So we're going to use a little kind of laser zap. And let me just look at the questions. Why is it private? You know, that's a good question. You totally could do public. The question is, why is throw speed private? If you were tweaking it, you might want to make it public. It's really a matter of preference. I just tend to, anything that I'm not going to adjust, I will keep private. But yeah, because it's because you might want to tweak it, you could totally make it public, and then you would be able to adjust it in the inspector. Good question. Okay, so we're going to add a couple more variables to our script. We're going to have a public audio clip called shoot sound. And so audio clips are an important part of the audio system in Unity. They're basically a variable type which refers to any digital audio file. So we can use files in the format WAV, AIF, MP3, or .ogg, which is the Ogg Vorbis compression format. And it basically refers to a sound file that we can import as an asset and then load into an audio clip slot. And so we're going to add an audio clip. We're also going to add a private audio source called source. And we're going to add 2 private floats. And again, these could totally be public if you wanted to kind of tinker with them, called vol low range. And we're going to initialize that to 0.5. And a private float called vol high range, and that'll be equal to 1.0. And we're going to use these to set upper and lower volume limits so that we can have a little bit of sort of random fluctuation of the volume of our projectile, just to make it feel a little less repetitive. And so let's do that. So first of all, let's just play our sound when we launch our object, and then we can do the randomization of the volume. So we'll just start by saying in our start function, we're going to get a component reference to our audio source. So we're going to say source is equal to get component audio source, And so this is just going to look up that audio source. And actually, we can change this start to an awake. So it'll happen before start if we want to do something else in start. So it'll be source equals get component audio source, and it's going to find the audio source attached to this object, which we have to attach in the editor. Let's do that now, actually, while we think about it. So here, we'll just go out of play mode and choose add component, audio source. We're going to turn off play on awake, which would mean that the sound would play as soon as the game started, which we wouldn't want to do unless we click the button. And so I'll just give you a quick run through of the components of... Hold on, I see the chat is going on. Let me give you a quick run through of the audio source components, and then I will take a look at the chat. Just want to refer you, if you want a deeper dive on the basic components, Mike Geig did a training about audio about a year ago where he kind of really talked through all these parameters. I'm just going to go through them quickly since we already have that up on the site, but just kind of for a review here. So we have a mute option, which turns off the audio source. Bypass effects, bypass listener effects, and bypass reverb zones all have to do with effects processors, which we can add to our audio signal chain using Unity Pro. This is actually going to be a little bit different in Unity 5, and if you want to check out, we have some content on the site about how the audio effects and the audio signal chain works in Unity 5, which is really, really cool, and I recommend you have a look at. So it's going to be a little bit different actually going forward, so I'm not going to spend a lot of time talking about these. Play on awake, we discussed. Loop just means that the sound is going to repeat to the beginning and play again when it finishes playing. And then priority means if we have many, many sources playing at the same time and we're running out of system capacity to play them, what we can do is we can say this sound is important or not important. So right here, it's kind of right in the middle, and generally speaking, that's fine. If you put it all the way down, it means it's very important, and if you put it all the way up, it means it's very not important. So kind of, if you're getting really kind of clustered up with a lot of audio sources playing and you find stuff dropping out or you're losing stuff, you can play around with the priority sources to say maybe your background sounds are not so important, but if you had some dialogue or other important kind of gameplay sound effects, you might want to set the priority for those a little higher. Volume is a volume control expressed as a float between 0 and 1. Pitch is how fast or slow, or more accurately, the frequency of the playback of the digital audio file that we're playing. So if we slow it down, if we lower the pitch, it's going to sound deeper in tone, and it's also going to play back more slowly. If we pitch it up, it's going to speed up, and we're going to get a kind of an Alvin and the Chipmunks kind of effect, assuming it was a voice. We're going to do some stuff manipulating pitch in this lesson, so we'll talk more about that. This is a 3D sound that we're using. So here we have the Doppler level. What the Doppler level does is it applies some pitch change based on how the object is moving in relation to the player. So if something zooms past your head, you get this kind of kind of bend in pitch as it flies past. Generally speaking, it's okay to leave it 1. If you find that you have sounds that are getting pitched in a way that you don't like, you can turn it off, or you could go for something more exaggerated. You know, this is something I'll just kind of leave you guys to play with. The roll-off is how quickly the sound fades away as we get further. And we have this table here to show us, here's the distance in units, and here is the kind of relative volume. So logarithmic, which is this kind of fairly steep drop in volume, is the default, but we could also choose linear, which is just a kind of a long straight line, or we could choose custom, where we can kind of draw in our own. I'm going to leave it on logarithmic because that's the default. And then we also have the pan level. How much panning are we going to hear with this sound? The spread, which governs the spread of the headphone, so sort of how far apart, sort of subjectively, your ears are. And then the max distance is at what point is this sound going to be completely attenuated and we're not going to hear it anymore. Yeah, so that's a quick run through of audio source. You can check out Mike's training for more about that and some examples, but we're just going to leave it there. What we are going to do is assign our audio clip. So I'm just going to grab this weapon player, pew, pew, and toss that into our audio clip slot. So I'm just going to pre-assign that because I'm just going to be playing that one sound again and again. And so what we're going to do, so let's jump back to Mono Develop. And now we are going to play our shoot sound. So I'm going to use play one shot. I just kind of like this better, although you also could use audio source.play. Both would actually work equally well in this case because we're only playing one sound. I just kind of use play one shot out of habit, although it is a little easier to do the next thing that we're going to do, which is setting the volume. So what we're going to do is we're going to say source, which is our variable of the type audio source, source.play one shot. And play one shot takes two parameters. It takes a parameter of the type clip. So we're going to say the clip that we want to play is shoot sound. And then what I'm going to do initially is I'm just going to set the volume, which is the second argument, or the second parameter. I'm going to set that to 1. And let's just save that, jump to the editor, and test. And what's going on? Oh, of course. Yeah. Whoops. So I need to add my shoot sound to my throw object script. There we go. Pew, pew. So you can hear, right, as we trigger that thing, it just has a very samey kind of sound. So I like when I'm doing this kind of stuff to add a little bit of randomness to these things. So what we're going to do is we're going to use our low and high ranges, and we're going to randomize the volume a little bit. So we're going to declare a float called vol, and then we're going to say vol is equal to random.range. Vol low range is going to be the lower limit, and vol high range is going to be the upper limit. So we're going to choose a floating point value between 0.5 and 1.0. And so this is just going to give us a little bit of fluctuation in the volume, and then of course we're going to set that using play one shot. And this is actually why I wanted to use play one shot, so that I could easily pass in that volume each time I want to play the sound, and because we're going to have a different volume each time. So let's save, jump back over to the editor, and give it a try. And this is going to be fairly subtle. But I just find that that just has a much more pleasing sound. You can just hear that each time you play it, there's just that little difference in volume, and it just sounds a little more real or a little more natural. You know, you never are going to hear in the real world the same sound exactly the same again and again and again, and especially if we're talking about a weapon firing, something the player is probably going to do a million bajillion times in your game. It's kind of nice to have that little organic flutter. Alrighty, so that's going to be good for our cube. What we're going to do next is we're going to address our smash boxes here, and we're going to have them play some sound effects when they are getting smashed and knocked around. Okay, yes, Michael Miko, we made audio clip and audio source. The clip is the sound that is going to play. So in this case, it's our laser sound. The audio source you can think of as like a speaker in the scene. So it's where the sound is going to come out of, and it could play any number of different clips, whereas that one clip is always going to be that laser sound, but we could load in an audio clip of somebody talking into that audio source next, or whatever. And you'll actually see in the next example, we're going to have an audio source that plays two different clips based on what's happening with the boxes that we're shooting at. All right, so that is our throw object class. And what we're going to do next is we're going to create another script. So we're going to go create C# script, and this one is going to be called crash sound. Okay, so what we're going to do is we're going to start by declaring two public audio clips. So we're going to have a public audio clip called crash soft, and we're also going to have a public audio clip called crash hard. These are going to be the two different sounds that we're going to choose between when we when we play our sound. Now let's just start really basic just by playing a sound when this thing hits, and then we'll add in some more fancy stuff in a minute. So we're going to switch start to awake, and we're going to do the same thing. We are going to say source. Oh, and of course I didn't declare my source. So we're going to have a private audio source called source, and we are going to say source is equal to get component audio source. Now, you could do this as a public variable, and not an animator. You could do this as a public variable and just drag and drop. That would be fine. I just find doing get component, I won't forget to drag it. It just gets done automatically and is a little more idiot proof because I definitely have the capacity to be an idiot when I'm working on these kind of things. So we're going to get rid of update because we don't need it. And we're going to declare a private function that returns void called onCollisionEnter. So we're going to say void onCollisionEnter, and it's going to take a parameter of the type collision called call. Now this is something you're going to use probably quite a lot if you're doing any physics stuff, and this is a part of the Unity API, not something that I came up with, and is pretty neat and useful. So what we're going to do is we're just going to start super simple just by triggering one of our samples when this thing gets hit, and I'll show you kind of the less exciting or less optimal way of doing this. So, and then we'll fancy it up a little bit. So we're going to say source dot play one shot and pass in. Let's start with crash soft, and we'll pass in 1 for the volume. So we're passing in the audio clip and then the volume that we want to play it at. And let's just start with that. Super, super simple. And we will go back to the editor, grab all our boxes and platforms. I'm going to choose add component, crash sound. And we will assign now from our sample assets folder, I am using under vehicles, car, audio. I'm using these car crash sounds. And so I'm going to select all of these objects at the same time and then drag crash soft to the crash soft slot. And we might as well do crash hard while we're here, even though we're not using it. Now, we're also going to want to add an audio source to all of these, which I'll do while I have them all selected. So we're going to say add component, audio source. We don't need to drop in the audio clip because we're going to be providing that when we call play one shot, and I'm going to turn off play on awake so they don't play as soon as I start the scene. So we've got our sounds in, and let's just give this a quick test. Okay, so that is just, you hear the objects kind of settling in because they've all got rigid bodies with gravity. And now, if we shoot at them, and you can hear, right, that adds a lot to our scene, substantially more exciting just with that one sort of not very exciting sound. So we are going to do something much cooler with some scripting. So we're going to jump back over, and what we're going to do is we are going to declare the other variables that we're going to need. So we are going to have a private float called low pitch range. Again, you could make this public if you wanted to tweak it in the editor. I just chose not to. A private float called, I just kind of like to not have so much stuff in the editor if I can avoid it, if I kind of know what I want. But, you know, depends. You can have a private float called vel to volume. This is velocity to volume, and it's going to be equal to 0.2. This is just a scaling value that we're going to use to use the velocity to control the volume, which is going to be really cool. And then we're going to have a private float called velocity clip split. So this is just going to be, we're going to take the velocity and we're going to choose what sample we're going to play. All right, we can delete this comment. We know what awake does. That's not even accurate. Okay, so the first thing that we're going to do is we're going to choose what clip we're going to play based on how hard this object was hit. So we're going to say if call, right, which is our collision parameter, if call dot relative velocity dot magnitude is greater than velocity clip to split, which in this case is 10. So if the magnitude of the velocity of the collision is greater than 10, we're going to play our first sound. I'm sorry, is less than 10, not greater than, is less than 10. We're going to play our first sound, which is going to be source dot play one shot. Actually, here, we'll just copy this line, right? This is it. Boop. There we go. Source.play one shot crash soft. If it's not, we're going to do source.play one shot crash hard. So if it's greater than 10, we're going to play our hard crash sound. And I'm just going to throw in 1 for now, and then we'll modify that in a second. Let's save that and try it out. Okay. So pretty fun. Definitely much more exciting, right? We could throw some particles in there, some breaking glass, or whatever you wanted. I've got some kind of a car crash sound, which is why it sounds so so glassy. But you can hear we get that initial impact with the crash and then the kind of clunk sounds as it bounces around and falls into place, which really makes it feel a lot more exciting than when we just had the clunk sounds. We've got that, right? And it sounds pretty good, but you can still hear we're getting those repetitive clunk sounds from the things when they're falling, especially because they're always playing at the same volume and it just sounds kind of unnatural. So what we're going to do, we're going to use the volume from our collision. So we're going to say, we're going to declare a float called hitVol, and it's going to be equal, again, to call.relativevelocity.magnitude times vel2vol. And so I'm just scaling the value that we're getting from call.relativevelocity.magnitude. I'm just scaling that by 0.2 just to get it into a range between kind of like 0 and 2.0, so it'll be useful for volume. But you would probably want to check what kind of values you were getting back from your collisions before you set that value. So that's kind of specific to this particular situation with the velocity that I'm firing the projectile at and so on. Okay, once we've done that, we are going to pass in hitVol to as our volume parameter for play one shot for both of these. So let's save it. Jump over, and now we should hear closer. Very nice. There you go. You can hear as they're settling, right, that the clunk sound plays softer when they're just kind of settling in, and that explosion is very loud when we first hit them. So just a kind of a little degree of realism there that, you know, that just makes it feel a little bit more lively and a little bit more fun. Now, the issue that we still have here, because these are samples, is that it's just, we're still playing that same sample again and again and again every time, and it still sounds kind of fake. So what we're going to do is we're going to pitch the sample. We're going to change the pitch of it and pitch it up and down slightly, so it's a little different each time, just to add another little kind of air of randomness and realism. So we're going to say, we're going to set the pitch of our audio source. We're going to say source.pitch is equal to random.range, low pitch range, and high pitch range. So it's going to generate, in this case, a value between 0.75, so 75% of the original pitch, so a lower pitch, and 1.25, which is a higher pitch. Let's save that. And so notice, right, we're setting the pitch before we play the sample, right? So we're setting the pitch of the source and then passing in the volume and the clip to play. All right, so let's try that now. So you can hear, especially with the clunks, right? They're just making them a little different from each other. And what I'll do, let's do actually really extreme examples so you can hear. Let's make it like 0.15 and 1.75, just so we'll have a really wide range so you can really hear what's happening. Because it can be a little difficult to hear. So you can hear that one super pitched down one taking a long time to finish. It's still a little cooler than just having them the same, right? But we're going to go for something a little more narrow range, maybe our 0.75 to 1.5. So we have a kind of a 75% variation. Now, this is going to be quite different for your different samples. Like if you have, while I was setting this demo up, I tried doing it with the laser. And because the laser has a kind of a pitch to it, a note to it, you really hear it. The pitching didn't sound so good, which is why I stuck with the volume. So these kind of sounds that are more noise-based will really benefit from this. Things like footsteps, gunshots, crashes, any kind of like white noise is going to do well with pitching. And anything that's more like, that has more tonal or pitch content, more like a note, you may hear it and it may sound a little weird. But yeah, so there we go. And let's see how we're doing on time. All right, very good. So let's shift over to a little Q&A, and hopefully that was interesting for you guys. I'll put the script up on the screen for those who want to follow. Okay. Yeah, oboe shape is correct. I just looked it up. Its magnitude is a little bit less performant than square magnitude. So you totally could rewrite this to do a version with square magnitude. I mean, in this case, it's a pretty simple demo. So you know, I was just kind of keeping it simple there. But yeah, you certainly could do that. Oh, good question. Who has really good sound effects? You know, I don't know about Unity developers specifically. A game that I really liked the sound on that I played recently was Hohokum on PS4. It's a really it's got a really simple art style, and I felt like they really kind of punched it up with the sound and gave it a really vivid feeling. I mean, hopefully, as you can see from this demo, this thing would not be very exciting without sound, right? But when you put the sound in, it kind of feels like, you know, we start to feel like we have a little game, even though it's just those gray boxes. The in-game sound effects well executed. So you mean like the implementation? Yeah, that's a good question. I'm trying to think of something that's kind of jumped out at me. I'd have to get back to you on that, but that is a good one. One game that I really like the sound on, this is more the sound design, is Don't Starve. They do some really cool kind of creative sound effects. And actually the guy who does the sound for that has a podcast called Beards, Cats, and Indie Game Audio, which is great about game sound. You can learn a lot from that. And one thing I'll just say, guys, I know this is a little bit of a tease, but one of the reasons I'm kind of staying more on the scripting side and not going super deep into like effects and processing and all that stuff is because with Unity 5 right around the corner, I'm going to revisit this territory because there's some amazing stuff that you can do with the new mixer and the new audio effects that's really, really fun and robust. So we'll definitely be coming back to this with that, and I'll probably do a dedicated session on music then. Yeah, actually, Sony just released on the Asset Store a pack of kind of horror sounds, so like bone crunching and organ gut squishing, which is on the Asset Store. I think it's called Sounds of PlayStation, something or other. But yeah, you can get that on the Unity Asset Store, which is pretty cool. Hopefully, we'll see some more stuff from them doing that because that's kind of fun. Yeah, Rakuru, totally agree. Horror, I mean, I would say a lot of games depend on sound effects. You know, sound is one of those things because it's not in front of your eyes. It's easy to miss, but like you turn the sound off and you realize how much less exciting it is. But yeah, horror games especially benefit from kind of scary sound, scary music, and you know, creepy sound effects for sure. Yeah, no problem, Jolly American. And actually, I can do a quick. There is no such thing as a stupid question. I totally agree with that. Squeezed Goblin, totally agree. I can do a quick looping music example. Let me just do that real quick because I remember somebody requested that before. So what we can do is we'll just create an empty game object and child it. Actually, let's just add it directly to the we'll just add it directly to the camera so it doesn't change in relationship. Yeah, background music, exactly. I got you. We'll add an audio source to the camera so it doesn't change in relationship to the player. And all right, this is actually a piece of music that I made for a personal project of mine, which is called Pollen. Let's just drop this in. So this is actually a loop. So basically all that means is that it gets to the end and it comes back to the beginning on beat, right? It's musically in time when it repeats, and there's nothing like you don't have sounds getting cut off or anything at the loop point. It'll come back around and play seamlessly. And that would be up to your composer or your sound designer to make sure that they're delivering you something that loops cleanly. And so I'm just going to take this, and this is just an audio clip like anything else. It's actually really easy. I'm just going to take it, drop it into the source, and then I'm going to keep play on awake on and turn loop on in this case. So it doesn't just play once, it'll continue playing, and then we can just play our scene. And of course we can adjust the volume if we want, using the volume here. So maybe we'll pull it down a little bit so it doesn't overshadow the, keep the sound effects nice and loud. And that's basically all there is to it. Now you can get more fancy with it and have the music changing based on different things and so on. And that is actually what we will do in another session. We'll do like a more fleshed out thing about changing music based on game events and so on. That's something I really want to do, and working with like different musical loops and stuff. So we'll definitely get there. But there's the super quick version of just how to get a loop going. Oboe Shape, just wondering, can an audio clip source pitch be changed in mid-play of the clip? Yes, totally. As at present, I have a 2D player's jump sound. Short jump is 0.1 seconds, and it repeats continuously through the jump cycle and alters pitch prior to each play, but sounds choppy. I was going to add one long tone. I was wondering if a pitch change would work in runtime of clip playing. Yes. Yes, okay, the thing about that is when you're changing the pitch of audio, if you're doing it, you're going to be doing it at the frame rate, right? So let's say you're running at 60 frames per second. You're only going to be able to change the pitch 60 times per second, and that's actually not fast for audio. You're going to hear artifacts and stepping. It's going to be like boo-doo-doo-doo-doo-doo-doo. You're going to hear it changing pitch. It might be smooth enough for you depending on how fast your game runs, but I would probably recommend putting a smooth bend into your actual sound and maybe triggering different samples based on like the jump, or you could maybe crossfade between different samples, but it's going to be hard to get a smooth pitch bend running at 60 frames a second or something. Can you fade in, fade out music? Yes, you totally can. I'm going to leave that for another session, but basically you could just do a lerp on the volume. That's one easy way to do it. Here, I'll put the scripts on the screen for anybody who wants to copy. Put the other one up. If anybody missed throw object, these will also get posted on the archive when this goes up in a couple of days. Okay, can you do ooh, wow, what a question. Can you do spectral analysis of sound, Fourier transformation, for example, in Unity in an easy way? It would be great to add special effects depending on frequencies and amplitudes of certain sounds and other stuff. Not in an easy way. That is some fairly advanced stuff you're looking to do there. In Unity 5, you have the capability to write your own plugins for the audio system. So if you wanted to write a FFT plugin fast Fourier transform plugin to do spectral analysis. My worry with that would be that is going to be pretty computationally intensive to be running alongside your graphics and everything else. So that would be a bit of a balancing act there. I would, if you do it, let me know. I would love to see it. But I know, for example, like in the 5 beta, there was some discussion about somebody who was trying to get live levels from the meters, not reading the meter from the mixer, but actually read the level in real time. And that is something that is not in 5 yet because it's very processor heavy. And obviously, we want everything to be as lean and fast as possible. So I think that might be the issue there. I mean, that's the thing. You could do that in a DAW, in a digital audio workstation, a piece of music software, fine, but it'll still be expensive. But here we're trying to run a whole video game on top of that, not just the audio. So maybe if your game was audio only, you could do that. That's what I'm saying. I think for sure it would be demanding. I would say think about the effect you're trying to achieve there. Think about why you're trying to do that. I'll bet you there is a less processor intensive way to achieve that same effect. Will sound diminish the further the other player is away from you? Yes, if the player has an audio source and like their footsteps, yes, they will diminish as you get further away. But yeah, if that is the question, as long as the other player has an audio source, let's say for their footsteps or their weapon or whatever, and the audio listener is attached to the current player. So this is going to be, I'm assuming, in like a networked multiplayer environment, right? Then yes, the audio source is attached to the camera. The audio listener is attached to the camera. If the other player is further away, their sounds will be quieter. If the source attached to the other player is further away, their sounds will be quieter.